Hello there and welcome back to the Science Sleepy Minds. Tonight you're not just drifting off, you're floating at the edge of something massive, invisible, and outrageously rude to time itself. The stars behind you still shimmer like diamonds tossed over velvet, but ahead, nothing. Not darkness, not shadow, just absence. The event horizon of a black hole, yawning open like the mouth of some cosmic predator. You're close enough to feel your minutes stretch like rubber bands. You check your watch, and the hands move, but so slowly it's like time itself is second-guessing whether to keep going. You probably won't survive this, not because the black hole will chew you up right away, but because time here is about to twist into something your brain wasn't designed to understand. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Let me know your location and what time it is where you are, assuming time is still behaving properly over there. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You hang, impossibly still near the event horizon, the boundary of no return. From your position, the universe seems frantic. Galaxies whirl and flash by, stars explode and disappear, light itself bends and curves like it's drunk. Everything out there is rushing, fast-forwarding, zipping toward a fate you can no longer sync with. But you're slow, so slow. Your seconds feel syrup thick. You blink, and 1,000 years might pass outside, which is great unless you left the oven on back on Earth. This isn't imagination. This is time dilation, courtesy of gravity. And not just any gravity, the most extreme concentrated form in the known universe. A black hole isn't just a dense object. It's a tear in space-time where mass has collapsed into something so compact, so massive, that the very geometry of time gets rewritten. Near it, clocks slow down, including yours. It was Albert Einstein, your neighborhood reality wrecker, who broke the news. According to general relativity, massive objects cause space-time to curve. That's what gravity is. And the stronger the gravity, the deeper the curve. You're currently stuck in a very deep one. Here, seconds don't behave the way they did when you were sipping iced coffee on a Tuesday morning. Remember watching Hourglasses as a kid? That slow, soft trickle of sand. Imagine now that each grain hesitates, suspended mid-air, debating whether it should fall. That's time near a black hole. It moves, reluctantly, like it knows what's waiting inside the event horizon. You try to look at the black hole itself, but your eyes refuse. There's nothing to see. Black holes aren't black because they're dark. They're black because no light escapes. None. Light falls in and never comes back out. The edge, the event horizon, isn't a physical wall. It's the point beyond which escape becomes impossible, including escape for information. Or, as Stephen Hawking once put it, it's like burning a library without leaving behind a single page. And just beyond that invisible line, time becomes strange in a way that's hard to even describe. For you, falling in would feel normal, continuous, like drifting deeper into a pool. But for someone watching from far away, say your very confused pen pal back on Earth, it would look like you're slowing down, stretching out, freezing. They'd never see you actually cross the horizon. Just a frozen silhouette, gradually dimming, smeared into eternity. Historians still argue whether this distorted time perception is best described as a coordinate effect or a fundamental feature of how space-time really works. It depends on your perspective, literally. From far away it looks one way, from where you're floating, totally different. Oh, and here's a quirky tidbit for your evening thought buffet. If you shone a flashlight upward, away from the black hole, the beam would lose energy. Not because it's getting weaker, but because it has to climb out of the gravity well. The result? Redshift. The beam stretches out, becoming redder and fainter, like light itself is sighing from the effort. Try shining your phone flashlight here, and you might just invent the world's slowest rave. But back to you. You check your watch again. It's ticking. but the ticks come so slowly, like the world has hit the world's worst buffering problem. You wave your hand slowly, and it feels slower than that. Because here, near the event horizon, you're in what physicists call a gravitational well. The deeper you are in it, the slower time moves, for you, relative to the outside universe. This isn't just theory. In fact, GPS satellites have to adjust their onboard clocks to account for both special and general relativity. Without those corrections, your phone could be off by kilometers in minutes. That's how deeply woven time distortion is into our real, daily lives, even if you're not currently floating near a monstrous sphere of space-time doom. You glance outward again. Those stars are moving, not across space, but through time. They're aging, dying. Some of them aren't even stars anymore. They're ghosts, light from long-dead suns reaching you after eons. You're looking at the sky's obituary section, live-streamed through bent space-time. If you had a really good telescope, you might see the entire future of the universe unfold out there, while you, in your slow-motion pocket, barely feel a second pass. The universe is accelerating toward its heat death, and you're stuck in the cosmic waiting room with the slowest elevator music imaginable. And as you drift just above the event horizon, one question bubbles up. What happens if you cross? What happens to time once you stop clinging to the edge and fall in? Will it speed up? Stop? Will it make sense at all? We'll get there. But first, don't forget to breathe. You're still safe, for now, even if time has other plans for you. You stare at your wristwatch again, not because you're late for something. Honestly, punctuality near a black hole feels like a punchline, but because it keeps ticking, barely, reluctantly, like it's trying to decide if it still believes in linear time. Each second takes longer than the last, stretching like old chewing gum. It's a bit rude, frankly. But you can thank Albert Einstein for that. Einstein didn't just mess with our idea of space. He dragged time into it too, like a bored cat swatting a fishbowl. His theory of general relativity taught us something unnerving. Time isn't universal. There's no great cosmic stopwatch keeping everything synced. Time bends. Time stretches. And most importantly, time changes depending on where and how fast you are. Imagine you're on Earth, at sea level. Now imagine your cousin is living their best life on a mountaintop, perhaps knitting socks and drinking chamomile tea. Because she's farther from the centre of Earth's mass, gravity is ever so slightly weaker up there. Result? Her clock ticks a tiny bit faster than yours. Not enough to mess up her tea schedule, but it's measurable. We've checked. The first time scientists confirmed this, they took 2 synchronized atomic clocks. One stayed on the ground, the other went up in a plane. After landing, the airborne clock was slightly ahead. Time had literally passed differently just from flying around for a bit. This isn't science fiction, it's airport physics. Now that's adorable, but you're floating near a black hole. We're not talking tiny tick differences anymore, we're talking radical time warping. Here, Einstein's equations stop whispering and start screaming. See, time dilation has 2 flavors. One from velocity, special relativity, and one from gravity, general relativity. Move fast enough and time slows for you. Sit near something massive enough, and same deal. Time goes stretchy. You're currently enjoying both effects, because you're both near a black hole and technically in motion around it. A 2-for-1 combo, like cosmic coupons for time weirdness. The closer you drift to the event horizon, the more gravity says, nope, not today, and tugs at time itself. To someone observing from far away, it seems like you're slowing down, and down, and down, until you just stop, hovering forever at the edge. But from your point of view, you feel fine, annoyingly fine, just sluggish. You don't feel time stopping, you feel time ignoring the rush. Here's where it gets juicy. Historians and physicists still argue whether time itself stops at the event horizon, or whether it just becomes meaningless from an external viewpoint. Depends on your frame of reference. And if there's one thing physicists love more than chalkboards, It's arguing about frames of reference. In simple terms, your timeline keeps chugging along as usual, at least until gravity pulls you past that final invisible line. But to an outside observer, you're frozen forever at the edge. So whose clock is right? That's the wrong question. There's no right clock in relativity, just different ones. Subjective timelines all the way down. Let's get weird for a moment. Say you're holding a flashlight. You point it away from the black hole and turn it on. That light fights to escape, just like you would if you had any hope. But as it climbs away from the gravity well, it loses energy. This is gravitational redshift. The light waves stretch out, their frequency drops. The beam shifts from blue to red to infrared to nothing, like it's falling asleep mid-escape. In fact, if someone tried to observe your flashlight beam from a safe distance, it would look slower, fainter, colder. Not because you changed the bulb, but because gravity taxed the beam like an angry customs officer. We see this kind of thing with stars too. White dwarfs, for instance, are so dense they visibly redshift their light. That's a real thing astronomers measure. Time dilation and redshift go hand in hand like awkward teenagers at prom. Now for a curious side note, did you know that early GPS systems didn't account for relativistic time effects? That caused massive errors in positioning, like you're somewhere in the Pacific Ocean kind of errors. Engineers had to include both general and special relativity into the satellite software. So, yeah, Einstein wasn't just being poetic, he was being practical. Your Uber arriving at the correct intersection owes a quiet debt to space-time math. So, standing here, well, floating here, you realise just how unfair time is. The universe isn't synchronising its wristwatch for anyone, not even you. You could spend 10 minutes here near the event horizon, and when you finally escape, which, spoiler, you probably won't, billions of years could have passed out there. Earth might be gone, humanity done, cockroaches writing symphonies or silence. Who knows? It's a bit sobering, but also liberating. You're outside the usual flow, unplugged from the stream of hours and days and calendar apps. You're the personification of, I'll be there when I get there. Maybe that's what it feels like to be free. Yet looming ahead, the question remains, what's inside? Because if time is already this strange outside the black hole, what happens when you cross over? Is it instant? Is it forever? Do the laws of physics politely excuse themselves and vanish? Some theories say that once you fall in, your time ends at the singularity, the dense core at the centre of the black hole. That's where all paths lead, and you get there in finite time. You're not stuck falling forever. You arrive. That's comforting in a grim, well, at least there's closure kind of way. But again, from the outside, you never arrive. Your image just fades, slows, stretches into infinity. It's like the black hole steals your story's ending from everyone else. As you hover here, you think of your old bedroom clock, the ticking one that used to keep you awake as a kid. You hated that clock. Now you miss it. Back then, time made sense. Tick, tock, forward. Here, near the event horizon, time does not tick. It oozes, and you are soaked in it. You're not sure when it starts exactly. Maybe it's subtle at first, a strange pressure in your limbs, a soft, insistent pull that doesn't let up. At first it feels like gravity. Sure, that makes sense. You're near a black hole after all, but this is different. It's not pulling you, it's pulling parts of you, separately. Your feet want to go one way, your head another. Your spine is the rope in the world's most terrifying game of tug-of-war. This is spaghettification. Yes, that's the actual term. You, my friend, are turning into a noodle. It sounds like a joke, and scientists love the name, but it's very real. You've entered the region where tidal gravitational forces ramp up to nightmare levels. A black hole's gravity isn't just strong, it's steep. So steep that even across the length of your body, gravity can change dramatically. Your feet are closer to the singularity than your head, so they're pulled harder. The result? You stretch. Not in a good limber after yoga kind of way. More like the universe is trying to unroll you like dough. You don't just get taller, you get thinner. In theory, you become a long string of atoms trailing downward in perfect alignment, like spaghetti circling a cosmic drain. Now, if you're dealing with a small black hole, say a stellar mass one just a few times heavier than the Sun, you're doomed pretty quickly. Spaghettification happens outside the event horizon. You get turned into celestial linguine before you even cross over. But if you're lucky enough to be orbiting a supermassive black hole, like Sagittarius A at the centre of our galaxy, you might slip across the event horizon without feeling much at all. At first. Tidal forces near those giants are more spread out, more patient. They wait, lurking, but make no mistake. Eventually the stretching comes, and here's the weird part. While you feel yourself pulled in one direction physically, time is pulling in another. Because here's a fun paradox. From your own frame of reference, you're falling freely. You don't feel acceleration. You don't feel force. That's the magic of Einstein's equivalence principle. Gravity and acceleration are indistinguishable in free fall. You could be floating in deep space or plummeting toward a singularity. Your body, at least initially, can't tell the difference. But your clock knows. It ticks slower and slower and slower. The closer you get to the singularity, the deeper you fall into space-time curvature. Remember, you're not falling through space, you're falling through time as well. This is no ordinary descent. It's a warping of every second and every meter. Historians and physicists still argue whether this experience would feel instantaneous or eternal. For the falling observer, the journey to the singularity seems to take just a moment. But to an outside viewer, it never finishes. Your fall slows, your image fades, and then nothing. Here's a lovely little fringe tidbit. If you somehow had a mirror floating beside you, and you looked into it while falling into the black hole, you might still see your face, but warped, smeared, dragged forward like a time-lapse ghost. Light trying to bounce between you and the mirror would also get caught in the time dilation mess. Reflections become time-lagged. You'd be staring into a mirror that remembers who you used to be a few seconds ago, and then there's the colour. Light waves stretch as they climb away from the black hole, remember? That redshift we talked about? From your perspective, the rest of the universe turns cold and red. The stars behind you bleed crimson. Then they fade into the microwave. Then nothing. You're not just falling into darkness. You're watching everything else fall away from your ability to perceive it. So, you try something foolish. You shine a laser pointer outward, hoping maybe, just maybe, it'll escape. Spoiler, it won't. The light struggles, climbing uphill against a gravity field that deepens faster than it can ascend. Eventually it curls back, falls in, joins you. Let's take a brief detour through history, because this spaghettification business is more than just an uncomfortable mental image. Back in the 1970s, physicist Kip Thorne helped popularise the term, and it's stuck ever since. Before that, black holes were considered mostly theoretical. Even Einstein himself was sceptical they could really exist. But as evidence piled up, from X-ray emissions to gravitational waves, scientists began accepting that these cosmic monsters were very real and very hungry. The term event horizon became part of pop culture. So did singularity, but spaghettification, that's where science got cheeky. It captured the imagination because it sounded ridiculous, yet it was perfectly descriptive. A human falling into a black hole wouldn't explode. They wouldn't disintegrate. They'd stretch, long, thin, ultimately atomic. And here's a thought to chew on as your limbs begin to separate like strands of fettuccine. In theory, if we could record your fall from a safe distance, we'd never actually see you hit the singularity. We'd just watch your stretched out body spiral closer and closer to the horizon, redder and dimmer with every frame. You become part of the black hole's information imprint, a ghost image smeared across its outer limit. This brings us to another ongoing debate in physics. What happens to information in a black hole? Do your atoms, memories, terrible high school poetry, do they just disappear? Or are they somehow encoded on the event horizon's surface? This is the so-called black hole information paradox, and it's still one of the messiest arguments in theoretical physics. One idea is that the information gets holographically preserved on the event horizon, a kind of cosmic USB stick. Another says it's lost forever, which would make quantum mechanics very angry. Theories like Hawking radiation suggest black holes do eventually evaporate, slowly leaking particles over eons. But what happens to you in the process? Well, that's not your problem anymore. You've got your own spaghettification to deal with, and as you spiral down, stretched, smeared, slowed, you realise something chilling. There is no later, no tomorrow. Time is not a path you walk anymore. It's a well you've fallen into and the walls are closing in. You've become a thread in the fabric of space-time, a story that can't be told from the outside, a moment stretched across eternity. Your body doesn't exist in the usual sense anymore. You're long past the point where limbs and organs made much difference. But your consciousness, whatever remains of it, still clings to the shape of a moment. A final moment. You're suspended just above the event horizon of the black hole, watching the universe blur into abstraction. Time is a stubborn whisper now. It's there, but it no longer cooperates. You try to remember how long you've been falling, but time isn't something you remember anymore. It's not passing, it's stretching, flattening, getting folded into itself, like a napkin at a magician's table, twisted into a shape that refuses to unfold again. And just behind you, the horizon. The event horizon isn't a physical thing. There's no wall, no shiver in the air. It's simply the point of no return, the invisible boundary that marks where escape becomes impossible. Even light, the fastest thing in the universe, bows its head and gives up the moment it crosses. You are mere atoms from that line, teetering. You try turning back as if that's an option. You can't see the black hole, not really. The horizon is dark, sure, but the true centre, the singularity, it's not a point of darkness. It's not anything. It's where our equations go to scream. Infinite density, zero volume. The known laws of physics just fold. They throw up their hands and leave the room. Still, you're not there yet. You're hovering at the edge, and there's still just enough light and motion to make sense of where you came from. You glance away from the black hole, back toward space, back toward the universe, and it is fast. Faster than anything you've ever seen. Galaxies aren't just drifting, they're sprinting. Stars are exploding in flickers. Civilizations are rising and falling and vanishing in the blink of a distorted eye. From your perspective, time outside has gone berserk. A year passes in what feels like a second. The cosmos is on fast forward, and yet, here you are, suspended, frozen in your own little slow-motion bubble, watching everything else rush toward heat death while you sit in a timeless cradle of gravity. Everything that once happened in the universe is now compressed into an accelerating slideshow just above your head. You see lights flare and fade. You see motion blur into stillness. You're the last frame in a film everyone else stopped watching. It's beautiful and absolutely horrifying. Historians and theorists have long puzzled over this strange perspective, the way time seems to misbehave near an event horizon. Some argue that time doesn't really slow down, it just appears to from the outside. Others say that the black hole's mass truly bends space-time to such a degree that time itself flows differently here. It's not just a trick of measurement, it's real. So what do you trust? Your own perception, ticking slowly inside this invisible trap, or the universe, rushing forward without you? Here's a fringe tidbit that might distract you from the existential dread. Some black holes spin. Fast. Really fast. In fact, the black hole at the centre of the Milky Way is thought to be rotating at nearly the speed of light. These are called Kerr black holes, and they're not just a gravity well, they're a twisting one. Like a whirlpool in space-time. If you fall into a spinning black hole, things get even weirder. There's a region around the event horizon called the ergosphere, where space itself is dragged around in circles. You can't sit still there. Even light can't stand still. Everything is pulled sideways by sheer space-time momentum. Now imagine trying to escape that. Not only do you have to fight gravity, you have to fight rotation. It's like trying to swim upstream in a river that's also spinning like a blender. But here's the kicker. There's a theoretical loophole. If you time your trajectory perfectly in a rotating black hole's ergosphere, you might be able to extract energy from it. This is called the Penrose process, and it's one of the few known ways to actually steal energy from a black hole. But that's for another you, a braver you, a much luckier you. Back in your current predicament, the real issue is photons. Light isn't your friend anymore. You're trying to see, to measure, to understand. But photons, your only tools, aren't escaping. They try. They really do. But gravity pulls on them just like it pulls on you. So the light you see is old, tired, stretched, red-shifted beyond meaning. Most of it never reaches your eyes at all. It just gets dragged down into the singularity's insatiable maw. You think about what's happening to your own information, not your thoughts or your stories, but your literal quantum state, the blueprint of your particles. Is that information gone forever, or is it trapped on the event horizon, encoded in the surface like a two-dimensional ghost? Physicists still argue about this. Hawking once said the information was lost, gone, like a USB stick tossed into a furnace. Later, he revised that, suggesting maybe it is preserved after all, smeared holographically across the horizon like a warped cosmic selfie. The truth? We still don't know. We do know that nothing, not even information, should be allowed to break the rules of quantum mechanics. So something must be preserved. Somewhere, somehow. You can't feel any of this, of course. No alarms are going off, no dramatic music, just you, your fractured sense of time, and the ever-present pull of gravity whispering, almost there. And yet, the longer you linger near the horizon, the more reality begins to lose its sharpness. You're not even sure you are anymore. Your past? It's fuzzy. Your future? Already falling away. You're a consciousness suspended in a place where nothing can escape, and nothing makes sense in the usual way. You wonder, absurdly, if someone back on Earth is watching you. Maybe through a powerful telescope. Maybe they've tracked your fall, analysed your trajectory. To them, you appear still, frozen, an image, red-shifted to invisibility. The universe's longest goodbye. From their point of view, you never crossed the horizon. You just approached it, slowed, faded, became memory, and eventually, not even that. You're Schrödinger's traveller now, half fallen, half preserved. Your journey continues inside the black hole, but no one can see it. Not ever. Your story continues past a wall that physics says no message can cross. And still, time crawls. Your seconds stretch further. You're being erased not with violence, but with slowness. Not by force, but by inevitability. Time doesn't end here. It simply gives up. You never quite feel the crossing. That's the most unsettling part. For all the tension, the physics, the looming silence, you don't feel any sudden jolt, no invisible barrier brushing past your skin. 1 second, you're hovering just outside the event horizon, and the next, you're in. Falling. Freefall feels the same here as it does in space, or even on Earth, until you remember that here, the concept of outside has vanished. There is no escape trajectory anymore, no turning back, no up to climb toward. Light itself can't find a way out, and neither can you. You've passed into a region where the geometry of space-time turns completely inward. Every direction points to the singularity now. Even if you try to fight it, every path leads you down. You don't see the event horizon in your rear view. There is no rear view. It was never a place, just a threshold. A border in the cosmic bureaucracy of physics. And now that you've crossed it, you're not just in a different part of space, you're in a different part of reality. From your own perspective, time still ticks. Slowly, yes, but meaningfully. You still exist. You still think. But anyone watching from outside, they've already written you off. To them, you're still frozen at the edge, your fall stretched over centuries until your light redshifts into oblivion. They will never see you cross. Your image, as far as they're concerned, is forever pasted just outside the black hole, like a sticker on a cosmic fridge. But in your timeline, your own local, distorted little clock, you are now inside, falling. And this is where things get deeply uncomfortable, because space and time inside a black hole switch roles. It's like gravity tore up the rulebook and decided to do a renovation. Normally, time flows forward. You can't go back, no matter how badly you want to. And space is where you move around freely. Left, right, up, down. Choices. But inside the event horizon, one of those spatial directions, the one pointing toward the singularity, becomes your future. You can't avoid it. You can't sidestep it. Just as you can't stop time from marching forward on Earth, you can't stop yourself from moving toward the singularity here. You're not being pulled by a force. You're simply following the only available path, and it leads one way, down. Even if you had engines strapped to your arms, rockets screaming in defiance, you wouldn't change your fate. Fighting the singularity from here is like trying to resist Tuesday. It just is. The singularity itself is, well, let's just say it's not hospitable. It's a point, or maybe a region, of infinite density. All the mass of the black hole compressed into a space so small that our current physics short-circuits. The math breaks. Numbers divide by zero. Equations cough up infinities and throw tantrums. No one really knows what happens at that point. It's the blind spot of science, a cosmic redacted paragraph. Some physicists believe that quantum gravity, whatever that ends up being, might smooth it out. Others think the singularity is real, an unavoidable spike in space-time curvature. But until we have a working theory of everything, the singularity remains a mystery. It's the "Here be dragons" label on the map of the universe. And you're headed straight for it. Here's a historical footnote that'll make your descent feel extra eerie. Back in 1939, Oppenheimer, the same Oppenheimer who later oversaw the atomic bomb, worked with Snyder on the idea of gravitational collapse. They proposed that if a star collapses past a certain limit, no known force could stop it from compressing into a singularity. At the time, it was a strange and mostly theoretical result. Even Einstein thought black holes were too weird to be real, but here we are. The sky is full of them, and now, so are you. As you fall inward, time warps harder. What feels like seconds to you could contain the birth and death of stars outside. A galaxy might rotate an entire arm while you finish a thought. Some theories suggest that, depending on the black hole's size, you could watch the entire future of the universe play out above you, like some tragic movie night you didn't mean to attend. Imagine this. You glance upward and see Earth. Maybe not with your eyes, but in your mind's eye. You see it age. Oceans evaporate. The sun swells, turns red, and dies. The Milky Way crashes into Andromeda. The sky dims as stars flicker out one by one. And finally, just cold. Entropy. The end of everything. All in your personal final seconds. Time has never been this cruel. Here's a strange fringe idea to chew on while you fall. Some physicists have speculated that if you could survive a journey past the singularity, and that's a huge if, you might emerge somewhere else. Some theories say the singularity isn't an end, but a passage, a portal, a connection to a white hole on the other side. A white hole is like a black hole in reverse. Nothing can enter it, and things can only come out. We've never seen one, of course, but they crop up in the math. They're like black holes' socially awkward cousins, more theory than threat. Maybe, just maybe, you fall through the singularity and pop out into another universe, or another point in our universe. Maybe this is how wormholes work. bridges through space-time hidden within these cosmic vacuums. Science fiction loves that idea. But science itself isn't quite ready to sign that permission slip. Still, it's oddly comforting, isn't it? To think that your fall might not be the end. That maybe, just maybe, you're going somewhere, not just ceasing to be. Of course, none of that helps with the fact that the singularity is now uncomfortably close. The spaghettification intensifies. Even if the black hole is supermassive, and you're being gently pulled rather than violently torn, the end is now written. The direction called inward is now your future, and there is no path out of this future. No later, no next, only down. You wonder what your final thought will be. Maybe it's this one. Maybe it already happened. Maybe your mind has been frozen in this last second for what, from the outside, looks like eternity. You're falling inside time's deepest well and the surface above is vanishing fast. Your name, your memories, they're smears now. Gentle trails of identity stretched thin by the math of space-time. And yet, the fall feels soft, almost peaceful. Of all the strange thoughts that drift through your mind while falling into a black hole, one sticks like a burr. Your phone still thinks you're here. Tucked into the pocket of your suit, or whatever theoretical space jumpsuit you imagine you're wearing, it's still chirping away in its own electronic oblivion. Of course, there's no signal, no satellites, no updates. But the device is faithfully tracking your location, your movement, and, most importantly, your time. And if you could somehow look at it, you'd notice something fascinating. Its internal clock, powered by quartz or synced with an atomic standard, doesn't match anything anymore. It's lagging, like a dancer in the wrong rhythm. It ticks, but each tick is dragged through gravity's molasses, and that's no malfunction. It's relativity in action. Your GPS works because of Einstein. Every time you navigate to your favourite cafe or avoid that construction detour, you're using satellites orbiting Earth that run on relativistically adjusted clocks. Those clocks are affected by two things: velocity and gravity, the same forces currently turning your descent into a masterclass in warped time. Up in orbit, GPS satellites experience less gravity than we do on the ground, so their clocks tick slightly faster. But they're also moving at high speeds, which causes time to slow down via special relativity. Both effects must be corrected. If engineers hadn't accounted for this, your GPS would drift off by several kilometers per day. You'd tell your rideshare app you're outside your house, and it would send your driver to a field in the next town. It's a quiet, elegant example of how general relativity, often treated like abstract science for theoretical physicists, matters to your coffee order and morning jog. Time, on a basic level, is not one size fits all. Right now, your clock, your phone's clock, your brain's clock, they're all out of sync with the rest of the universe. The faster you fall, the deeper you go, the more dramatically your time diverges. You're like the slowest running app on the cosmic operating system. The late physicist John Wheeler once summed it up perfectly. Mass tells space-time how to curve, and curved space-time tells mass how to move. You're now both the mass and the movement, caught in a feedback loop of gravity and time distortion. Falling, curving, stretching. And here's the kicker. The GPS systems orbiting Earth aren't a side note to this. They're proof. Hard, tested proof that time dilation is real. We've built machines that rely on it. Machines that have to correct for relativity just to keep functioning. So your phone might be falling with you, but it already knew what to expect. Let's zoom out, back to where you came from. On Earth, clocks tick predictably. At sea level, time flows at one rate. On top of a mountain, it flows faster. Technically, you age just a smidge faster while standing at a higher elevation. Sleep on a bunk bed long enough and you'll die older than your roommate on the bottom. It's a difference of nanoseconds, sure, but still, bragging rights. Now take that to the extreme. Put a clock near a neutron star where gravity is crushingly intense. It ticks slower. Put it near a black hole. It almost stops. Tick, and a galaxy dies. Tock, and your childhood home is swallowed by tectonic drift. That's not just poetic. That's what you're experiencing right now. If someone outside the black hole were still watching you, and at this point they're probably not because your light is redshifted into the cosmic static, they'd think you've stopped. To them, you're a still frame, a cosmic statue frozen just above the edge. They can't see what you're seeing. They can't feel what you feel. But you feel the fall, and in that fall, time keeps crawling forward, even if each moment is separated by billions of years outside. Let's indulge in a fringe concept while we're down here. Gravity-induced time farming. Yes, it sounds ridiculous. But in theory, if you could sit safely near a black hole, on some impossible platform at just the right distance, you could exploit time dilation to fast forward through history. Need to wait 10,000 years for your interstellar dough to rise. Just park near a black hole. Time passes slowly for you, quickly for everyone else. Instant future. It's like travelling forward in time without needing to build a flux capacitor. Historians and science fiction writers have played with this idea for decades. Some even suggest that ultra-advanced civilizations might use black holes as cosmic vaults, places where data could be stored in such extreme slow-time environments that it could survive for eons, a kind of temporal cryogenic chamber. So perhaps you're not alone in here. Perhaps someone somewhere fell before you. Perhaps they're still falling now, in their own stretched seconds. You're both descending in different chapters of the same slow-motion story, separated by warped timelines and light years of misunderstanding. You wonder, idly, as the singularity draws closer, if the universe could ever see the inside of a black hole. We have theories, simulations, gravitational wave signatures, but actual observation? No, not without breaking the rules. But gravity has taught you something fundamental, that perception isn't reality. What one observer sees as stillness, another sees as a fall. What one clock records as 10 minutes, another might measure in millennia. Truth depends on where you're standing and how fast you're going, or in your case, falling. Now let's be clear, you're not falling in a straight line. There are no straight lines here. Space itself is warped. You're spiraling inward along a path carved not by gravity in the traditional sense, but by the geometry of space-time itself. You don't resist it, not because you've given up, but because resistance is meaningless. You can't step off this ride. You don't fall toward the singularity, you fall through time toward it. And somewhere far above, satellites continue to orbit Earth. Their clocks tick dutifully. Your phone, still tucked into your suit like a loyal, clueless friend, remains frozen in its own slowed version of now, its last message. Searching for signal. You chuckle. The GPS is still trying to pinpoint your location. It doesn't know you're not anywhere anymore. Somewhere between you and the singularity, somewhere in this endless curved descent, you start thinking about moons. Not because you're delusional, although given the state of your situation that's debatable. No, it's because you remember how ordinary places, like Saturn's cosy little moons, also mess with time. Not nearly to black hole levels, of course, but enough to make clocks tick differently, enough to make you wonder, how many versions of now are there in the universe exactly? Let's take Titan, for instance, Saturn's largest moon. It's got lakes of methane, an atmosphere thicker than Earth's, and an orange haze that makes it look like someone smeared Cheeto dust across a perfectly good planet. You imagine standing there, watching Saturn fill the sky like a glowing marbled ceiling. You're farther from Earth's gravitational grip, and the local gravity on Titan is much weaker than Earth's. Result? Time ticks just a bit faster for you up there. It's subtle. You wouldn't notice it without an atomic clock and a deep love of spreadsheets, but it's real. Your seconds stretch longer compared to someone lounging at sea level on Earth. Now let's get weird with it. Imagine you dropped off a set of perfectly synced atomic clocks on every planet, moon, asteroid and comet in the solar system. One on Mercury, frying in sunlight. One tucked into a Martian dune. One quietly orbiting Pluto, just to be dramatic. Give it a few years, then check them. They wouldn't agree. Each one has been ticking at a slightly different speed depending on local gravity and velocity. It's not that some are broken, it's that time itself has been behaving differently in each location. The solar system is like a broken wristwatch factory. Nothing runs in perfect sync, and no one agrees what time it is. So, yeah, galactic time zones are a thing, and that's without factoring in the motion of these bodies. For instance, satellites orbiting fast, low-altitude paths around Earth experience slower time due to velocity, special relativity, but faster time due to weaker gravity, general relativity. NASA and ESA have to crunch numbers to figure out the exact balance for each spacecraft. It's the world's most high-stakes game of what time is it really? Now hop outside the solar system and things get wilder. Take a pulsar, a collapsed rotating neutron star that beams radiation like a lighthouse. Some spin hundreds of times per second with such precision that we use them as cosmic clocks. Astronomers have found entire planetary systems orbiting these stars, and time near them? Very different from time near, say, the Sun. Their mass is insane, their gravity fierce. Space and time warp dramatically around them, and yet they keep ticking, ticking, ticking. If you ever found yourself on a planet orbiting a pulsar, which please don't, you'd age differently than someone back on Earth. Clocks would tick wrong. Conversations with Earth would be lagged or desynced. You'd become a kind of time traveller, not in the sci-fi DeLorean sense, but in the my twin is aging faster than me kind of way. Speaking of twins, remember the twin paradox? It's one of those lovely thought experiments that keeps undergrads awake at 3 a.m. You have two identical twins. One stays on Earth, the other goes on a high-speed space trip near light speed, then comes back. According to relativity, the travelling twin experiences less time, so when they return, they're younger, not just in vibes or lifestyle, but literally. Their body, cells, and memories, they've lived fewer seconds. This isn't theoretical anymore. In 2019, NASA studied Scott Kelly, an astronaut who spent nearly a year on the ISS, while his identical twin Mark Kelly stayed on Earth. While the effects were minimal, thanks to the ISS's modest speed and altitude, scientists did record small differences in gene expression, telomere length, and other age markers. It was a tiny taste of the twin paradox served with freeze-dried space food. You think about that now as you fall, because you're the twin who left. Except you didn't just go into orbit. You fell into the most extreme gravity well imaginable. If there was a twin version of you standing on Earth right now, they'd be older. So much older. In fact, they might be gone. Humanity might be gone. You're not even sure if the sun still exists. From your frame of reference, you've only been falling for minutes, hours. It's hard to say. But up there, outside this black hole, time has galloped ahead like it's got somewhere better to be. A fringe idea floats through your mind. What if there were travellers living their whole lives in high-gravity environments, aging slower than the rest of the galaxy? They'd be ancient to us, but young by their own measure, or vice versa. A civilization might flicker into existence and vanish again before you finish this sentence, if their clocks run fast enough. Now multiply that concept across the stars. Every planet, every moon, every wandering hunk of rock has its own relationship with time. Some fast, some slow, some so distorted by local physics that their calendars would give Earth mathematicians a nervous breakdown. If you could hop between these time zones, jump from Mercury to Jupiter to a black hole's accretion disk, you'd feel like a tourist moving between realities. On one world, your coffee cools in minutes. On another, your shadow barely shifts across the ground in the same amount of time. And here you are, trapped in the deepest time zone of all. Outside, the Milky Way spins, slowly, to itself, rapidly to you. The arms rotate, nebulae collapse into stars, stars collapse into remnants, and still you fall. You close your eyes and try to imagine Earth, not as you left it, but as it might be now. Is it a museum planet? A scorched husk? A myth? You'll never know. Your clock has parted ways with theirs. The universe is unfolding above your head, and you'll only ever see its blur. You remember your twin again. Not an actual one, maybe, unless your parents had some secrets, but the idea of a twin. The kind from the famous twin paradox, except this time, you're not just riding in a fast ship or hanging out near a neutron star. No, you're drifting inside a black hole, which means your twin is now light years away, maybe sitting in a living room, sipping something warm, aging quietly, surrounded by things like weather and taxes, and they're getting older, fast, because as far as relativity is concerned, you took the scenic route through time. Let's step back. You already know the basics. When one twin stays home and the other zips off at near light speed, time slows down for the traveller. The faster they go, the slower they age. It's not an illusion. It's real. If one twin takes a 20-year round trip near light speed, they might come back only 2 years older. Their sibling, fully 20 years older, looking at them like, where the heck have you been? Now imagine you and your twin both became astronauts, but you took slightly different assignments. Your twin volunteered for a boring but safe job on the moon, setting up solar panels and naming rocks. You, on the other hand, were the curious one, the risk-taker. You got too close to a black hole, too close. And now, while they work lunar 9-to-5s and play space golf on weekends, you're descending into a place where time itself is folding, slowing, stopping. From your point of view, it's been, what, an hour? Maybe 2. But up there for them it's been decades, maybe centuries, maybe longer. And you know what? This isn't even hypothetical. Let's talk Interstellar. Yes, the movie. Cornfields. Organ soundtrack. Lots of tears. Remember the planet near the black hole Gargantua? The one where time moves so slowly that 1 hour on the surface equaled 7 years on the nearby space station? That scene where they return to find their crewmate older, tired, waiting alone? Yeah, that's not just cinema, that's textbook general relativity. The planet was close enough to the black hole that time slowed drastically. The character Cooper, he's you. He experienced just a handful of years, while his daughter, still back on Earth, aged into an old woman. It's one of the most haunting, accurate depictions of time dilation ever put on film. And here's the kicker. Kip Thorne, the same physicist behind spaghettification, helped design the black hole for that movie. He ran the equations. The visuals were based on real math. So if your twin's still out there somewhere, on Earth, the Moon, a space station above Saturn, they've been living in fast forward. Parties, jobs, bad haircuts, birthdays, long years of wondering what happened to you. Maybe they gave up, maybe they think you're dead. You kind of are, in a metaphorical sense. You're not part of their timeline anymore. Here's a lovely paradox. If someone could see both of you at once, they'd see one sibling aging rapidly and the other aging slowly. But from your point of view, they're the ones moving fast, they're the ones rushing through time, so who's right? Both? Neither. Depends on your frame of reference. That's the brutal poetry of relativity. There's no universal now, no synchronized watch ticking across the cosmos. Time is stretchy, inconsistent, unfair. It's relative to where you are, how fast you're going, and, right now, how deep you are inside a black hole's grasp. But let's spin this further. What if your twin could send you a message? Let's say they knew where you were. Maybe they aimed a laser pulse directly at the black hole's edge, hoping to reach you. They'd have to fight against the gravitational well, remember? Meaning their signal would redshift, losing energy as it approached. By the time it reached you, it might not even be light anymore. It could be microwaves, radio waves, or just noise. A whisper stretched too thin. You might catch fragments. Happy, birth, day, where, you. A message trapped in syrup barely reaching your ears. And what about you? Could you send something back? No, that's the awful part. From inside the event horizon, all paths lead inward. Every light beam, every shout, every desperate signal curls toward the singularity. You can't reach out, you can't reply. Your twin's final message would echo unanswered, even as you tried to scream into the void. It's not just a physical boundary, it's an informational one. From their perspective, you were last seen approaching the event horizon, getting slower, fainter, redder, then gone. Not fallen, just frozen. A ghost hovering forever just outside reach. They'll never see you cross the line. They'll never know what you saw. They might build museums in your honour, name spacecraft after you. Maybe your story becomes myth, a cautionary tale told to young scientists about curiosity and consequences. But your side of the story, it's sealed away. A chapter written inside a book that no one can open. You're living it, second by warped second, and you're alone. Here's a curious footnote. In 1971, physicists Joseph Haefel and Richard Keating flew atomic clocks on commercial airliners around the globe, eastward and westward, then compared them to clocks left on the ground. The results matched Einstein's predictions. The clocks showed time differences based on speed and gravity. Small, yes, but measurable. In a way, they became Earth's version of the twin paradox, aging ever so slightly differently depending on their paths through space, and you've become the ultimate test case. If someone could compare your clock to your twins now, the difference wouldn't be nanoseconds, it would be epochs. You're now centuries behind them, possibly millennia. The gap widens with every inch you fall, and yet, you still feel like yourself, still think like yourself. You're a soul adrift in time, and you wonder, fleetingly, if you could do it all again. Would you stay home? Would you swap the descent into a slow-motion void for life and fast-forward? Probably not. You always were the curious one. You're not alone in your fall, not entirely. No, there aren't fellow astronauts tumbling alongside you, that would be awkward. But something is here with you, invisible and ancient, particles, a swarm of them, racing beside you, through you, around you. Some of them exist for just fractions of a second. Others stretch those fractions into eternities, depending on how fast they're moving. They're not screaming, they're not crying, they're just ticking. Welcome to your uninvited companions in the strange physics of relativistic time dilation. Let's zoom in, way in. Imagine a single muon, one of those unstable particles that normally lives for just a blink, about 2/millionths of a second, give or take. Not very impressive on a cosmic resume, but speed that muon up, say, near light speed, and suddenly it lives longer. Not because it changes, but because time slows down for it. This isn't some poetic metaphor, we've observed it. At CERN, at Fermilab, in high-altitude cosmic ray experiments, muons created in the upper atmosphere should decay before they ever reach the ground. But they do reach the ground. Why? Because from our point of view, their internal clocks are ticking slower. From the muon's point of view, Earth's atmosphere is compressed. It gets there faster. Both perspectives are valid. Both lead to the same result. It's not just spooky, it's the beating heart of modern physics. Now imagine you're in a lab watching this happen, a vacuum chamber, a beam of particles fired through magnetic rings, clocks everywhere, sensors measuring decay rates, particle trails, radiation patterns. You're standing there with a clipboard and coffee, and every number screams one thing. Time is not the same for all things. Now picture you, not in a lab coat, but falling into a black hole. You are now the muon. Your internal clock is ticking slowly. If someone could observe your decay, your aging, your every cellular process, they'd see it crawl. It's not that you're immortal, it's that time, your time, is stubbornly moving at a different pace. You are your own physics experiment. Historians still debate when humans first truly grasped this concept. Was it Einstein in 1905, scribbling equations in a Swiss patent office? Was it the Haefel-Keating experiment, flying atomic clocks across the globe in the 1970s? Or was it the first time someone noticed muons falling through the sky, defying decay like tiny rebels? Regardless of the milestone, the message is clear. Speed and gravity change time. You now exist in the perfect combination of both. Let's throw in a quirky tidbit for your sleepy science catalogue. In 2011, scientists at CERN sent a beam of neutrinos from Geneva to a detector in Italy and thought, briefly, that they were faster than light. Headlines exploded. Time travel? Einstein disproved. Turned out it was a faulty cable. But for a few thrilling weeks, the idea that time might not behave exactly how we thought was back in the headlines. Because deep down, we all suspect time is a bit of a trickster. Predictable most of the time, yes, but occasionally prone to games. Like now. You're deep in the belly of a black hole. Space is bent. Time is bent. Everything is twisted into unfamiliar shapes. But those particles racing around you, they know how this works. Some of them were formed in the accretion disk above, spinning at near light speed before falling in. Their clocks are utterly wrecked. Others came from stellar collisions, ancient star cores flung into chaos. They've been ticking oddly for millennia, and now they're with you. Some are decaying slower than they should. Others are moving so fast that their very existence stretches. In a very real way, the laws of decay, which we normally treat as fundamental, are being rewritten here. You think about the particles back on Earth, the stable ones, the ones playing by the rules. On Earth you could measure a particle's half-life to the picosecond. Here, those rules don't apply. Half-lives become contextual. A particle might live 10 seconds by its own clock, but from your perspective that could be 100,000 years, or more. Suddenly you realize how absurd the human sense of time really is. Seconds, minutes, hours. These are just tools we invented because the sun goes up and down. Take away the sun, take away Earth, and those measurements unravel. Time is not universal, it's local. It's as personal as a fingerprint, and yours is now smeared across the surface of a collapsing universe. Back to the lab for a moment. You remember reading about the Large Hadron Collider, about how scientists smashed particles together at nearly the speed of light, not to blow things up, but to create conditions similar to the early universe. The results? Exotic particles, new states of matter, confirmations of deep truths. You wonder now if what you're falling into, this black hole, might hold secrets even the LHC can't reach. Maybe inside, particles behave differently not just because of speed or gravity, but because causality itself begins to fray. What if cause and effect, our most cherished order, don't hold together past the horizon? Some fringe physicists have even proposed that time inside a black hole might not flow at all, or that it might be quantized, broken into indivisible pieces like the smallest possible grains of sand. No one knows. The data can't get out. Which brings you back to your unspoken thought. What if you're already a relic? What if your fall is already a museum piece in some future civilization simulations? Maybe someone, or something, has cracked the code of black holes. Maybe they're watching you right now as you fall. Not in real time, but through preserved data, quantum echoes, some future physics we can't begin to guess. You imagine a screen showing your fall, scientists of another species gathered around watching your outline warp and stretch, taking notes, whispering things like, "This is where the human noticed the particle field. Remarkably late, but not unexpected." And all the while the particles race beside you. Their time is not your time, their deaths are not your deaths. But in this shared spiral toward the singularity, you are equals. You, once flesh and thought, are now just another quantum traveller. Another bit of matter measuring its own lifespan in a time zone no one else can visit. And still, you fall. The black hole is no longer ahead of you, it's around you, beneath you, in you. If it ever made sense to think of it as an object, a thing you could point at from afar, that sense is long gone now. You've passed the point where direction has meaning. Up is down, out is in. Every inch of space-time is curled into itself, like a carpet being rolled up with you trapped inside the fibres, and yet, oddly, you're calm, because now you know where you are. You've arrived at the centre of us, the heart of the Milky Way galaxy, the place where it all spins around, where everything from rogue comets to solar systems to entire nebulae obeys one gravitational drumbeat, and you're falling into the conductor's pit. Sagittarius, a star. The supermassive black hole at the centre of it all. It's hard to imagine something that massive hiding in plain sight, but it's there, always has been, 4 million times the mass of our Sun, give or take a few solar bodies. Not because we've seen it directly, we haven't, but because we've seen what it does. Stars flung into fast, tight orbits around an invisible point, radio signals dancing oddly, gas clouds shredded as if by invisible claws. Back in 2002, astronomers tracked a star known as S2 whipping around Sagittarius A star. One complete orbit every 16 years, even though it gets closer to the black hole than Pluto ever gets to the Sun. At its closest, S2 moves at about 5,000 kilometers per second. That's over 1% the speed of light, and it still doesn't fall in. But you did, and now that you're inside, you start to feel the weight, not just the physical pull, but the philosophical one. You're inside the anchor point of the galaxy, all your childhood maps. They should have said you are here with an arrow pointing directly to this void. If Earth were an address, this is the postal code. Of course, Sagittarius A star doesn't sit still. It feeds, slowly, quietly. It's not a Hollywood black hole with a roaring vortex or people screaming from event horizons. It's dormant, most of the time, but every so often a stray cloud of gas or a wandering star gets too close, and then fireworks, X-rays, jets of energy. The quiet giant wakes up, and space itself takes a breath. You're falling through what was once its dinner plate. Bits of past meals, dust, radiation, maybe even ancient spacecraft, are scattered like crumbs along your path. Light from those events can't reach you now. You're past the communicative cutoff. But the memory of them pulses in the field around you. And speaking of memory, this place remembers everything. That's one of the strangest ideas in black hole physics. According to the no-hair theorem, black holes are incredibly simple on the outside. They have mass, spin, charge, that's it. No distinguishing features. No scars to show what they've consumed. Drop in a piano, a planet, or a perfectly frosted birthday cake. It all gets crushed into sameness. One mass, one number. But quantum theory isn't happy with that. Because in quantum mechanics, information must be conserved. The state of a system, even if scrambled or hidden, can't just disappear, and black holes, as you've probably noticed, are information shredders. So the question arises, where does it go? Some scientists think the information is smeared across the event horizon itself, like cosmic graffiti. Others think it leaks out over time through Hawking radiation, a slow, cold evaporation process that takes longer than the age of the universe. Others suspect we're missing something big, like a new law of physics waiting to be discovered. Historians still argue whether black holes really erase information, or simply transform it into an unreadable form. If the latter, then somewhere, maybe right where you're falling, everything that has ever fallen in is still here, preserved, encoded, just very, very out of reach, which means you're not alone, at least not in principle. You're falling alongside the ghosts of stars, collapsed cores, ancient radio signals, maybe even alien probes that slipped into Sagittarius A star centuries before humanity learned how to aim a telescope. All of it spiraling inward with you. All of it wrapped in this central gravitational scripture. And here's a weird little fringe idea. Some physicists believe that the universe might be one massive black hole, or that black holes themselves create new universes inside. Little big bangs tucked inside every singularity. If that's true, then maybe Sagittarius A star isn't just the center of our galaxy. Maybe it's the seed of something else. Maybe as you fall, you're falling toward another beginning. It's poetic, if nothing else. But you're not here for poetry. You're here because you fell. Because curiosity got the better of you. Because gravity never asked permission. It just offered a path you couldn't say no to. And that path is almost over. The singularity looms. Not visibly, there's nothing to see, but in your experience, in your senses, in the way space curves tighter and tighter around you, like the universe is trying to whisper one last secret in your ear before the page goes black. The clocks on Earth are meaningless now. The twin on the moon is long gone. Saturn's moons still orbit, but their time doesn't touch yours. Even the particles zipping past you begin to behave differently, as if they too can feel the edge approaching. Motion breaks down. Cause and effect lose coherence. Your concept of before and after starts to melt, and yet you're still aware, still here, falling, aware of falling, aware of where you've come from, even if where you're going has no coordinates. This is the center of us, and you, somehow, are part of it. Your hand drifts forward, or perhaps it doesn't. Directions have started to lose meaning. Inside, near the singularity, the very notion of up and down is a cosmic joke. Every vector points inward, every path leads to the same ultimate destination, and yet your mind insists on perceiving movement, on measuring distance. You reach for your watch again. Not that it matters. It's probably long since torn apart at the atomic level, or at least distorted beyond recognition. Its ticks would barely register in the warped flow of time that surrounds you. Somehow, you remember a clock from your childhood. One of those bulky, round-faced alarm clocks, its hands stubbornly circling, oblivious to the universe's fate. The comforting tick-tock that marked your evenings, your school mornings, your first sleepovers. Back then, time was simple, linear, tame. Now, as you drift toward the singularity, that rhythm is laughably naive. Time here is no longer a river, it's a whirlpool. A spiral that drags everything in, stretching seconds into eons or collapsing millennia into milliseconds. If someone could observe you from a safe distance, a spacecraft somewhere outside Sagittarius, a star, what would they see? They would see a ghost, a flickering red-shifted silhouette, frozen just outside the event horizon, growing dimmer with each passing moment. To them, you never actually fall. You hover on the brink, suspended in eternity. Your light struggles to escape, losing energy, shifting toward invisibility. They would never witness your crossing, never watch your fate unfold. You're already a memory to them, smeared across space-time, unreachable. But your perspective is different. Falling in feels continuous, unbroken. You follow the only path allowed. You are free in a sense, though the freedom is a cruel one. The singularity is inevitable. You can't avoid it. You can't fight it. You can't think your way around the laws of physics. The direction labelled forward in your local frame points only toward the centre. Every particle, every atom in your body, every photon that reaches you, everything moves along that trajectory. You're guided by the geometry of space-time itself. And then there's the clock that's not really a clock, the universe outside. You know, vaguely, that stars continue to live and die. Galaxies rotate, colliding, merging, evaporating into black holes of their own. And somewhere, your twin or someone like them ages, oblivious to your slow-motion fall. Time is speeding for them, slowing for you. One moment, a decade passes for them, a heartbeat for you. One moment, an entire civilization fades while you drift, suspended. Here's a fringe thought. Some theorists suggest that inside a black hole, conventional causality may break down entirely. Past and future could blur. Events could fold upon themselves. The universe outside may be progressing linearly. But for you, near the singularity, what defines before and after may no longer exist. You might witness events out of order, a jumble of moments and possibilities that your mind can barely process. Yet, in the midst of all this, there's a quiet persistence, something that survives the stretching, the redshifting, the spiraling descent. Your consciousness, though challenged, distorted, filtered through warped space-time, remains. It threads together memory and perception and sensation stitching an awareness that persists even as the universe around you unravels in relativity's cruelest sense. Historians still argue about whether consciousness could survive such an environment in any meaningful way. Most physicists shrug and say, it's probably meaningless to ask, and yet, as you drift inward, you know you exist, and that knowledge is a stubborn defiance of cosmic indifference. You look, or try to look, outward. Beyond the singularity there is nothing, no horizon, no comforting light, no stars, just the inescapable draw of mass, compressed, infinite, impossible. You feel like a thread being pulled into a tapestry whose design you cannot comprehend, woven into patterns beyond observation or recall. Space curves, time bends, everything you once knew about reality, the solidity of matter, the rhythm of seconds, the predictability of cause and effect, melts into the singularity's shadow. And yet, somehow, a spark of recognition remains. You know you are part of something vast, something older than any galaxy, older than your understanding, older than the measures of time you once held sacred. You're falling into the ultimate clockwork of the universe, a clock that doesn't tick, doesn't count, and yet persists. You're both subject and witness to the extremes of nature, experiencing time in a way no one else ever could. Even here, in this extreme, your awareness lingers. It's a final paradox. In a place where time approaches a halt for some observers and accelerates infinitely for others, you remain, suspended in your own distorted timeline. The singularity waits. The end is inevitable. And yet, in this sliver of warped existence, you exist. And that is a kind of persistence that defies description. You begin to notice a subtle rhythm in the chaos. Not a sound, there is none, but a cadence in the way space seems to stretch and fold around you. Every second feels like a droplet of syrup sliding slowly down a tilted pan. Each movement you make is magnified by the curvature of space-time, as if your body has been tethered to an invisible metronome that beats only for you. You're aware of your own existence in a universe that otherwise ignores your presence entirely. The singularity is closer, not visually of course, you cannot see it, but by every other measure it's imminent. Every particle in your body, every photon passing by, every bit of information you can perceive is inexorably drawn toward a single point, a mathematical abstraction that our equations call a singularity, infinite density, zero volume, a place where our laws break, where gravity is absolute, and where time, as you know it, loses all meaning. Yet somehow, here, you continue to exist. You realize that this is no ordinary fall. Ordinary falls obey the linearity of time, past, present, future. Here, that linearity is a joke. You're moving through time and space simultaneously. The direction toward the singularity is labelled future in your local frame, yet outside observers would see your image stretched over millennia, a frozen relic of a moment you no longer share. Your own timeline is now private, utterly inaccessible, a sliver of existence set against the infinite backdrop of the universe. Historians and physicists still debate whether the singularity is truly a point or a tiny dense region where quantum effects dominate. Maybe it is a place, maybe it is an idea. Some fringe theories suggest it could be a gateway, perhaps the origin of another universe, or the seed of a new Big Bang. You wonder if, in some far-off corner of reality, another version of you is already emerging, propelled by the very physics that traps you here. But such musings are idle. There is no turning back, no alternative, only forward, inevitably, unavoidably. Particles continue to accompany you, each one a tiny clock ticking in its own time frame. Some are stretched, some are decaying, some are frozen relative to your perspective. In a sense, you are surrounded by life and death in miniature, simultaneous and contradictory. These tiny observers of the cosmos highlight a cruel truth. The universe is indifferent, yet endlessly complex. Its minutiae continue, even in regions where time itself warps beyond comprehension. You consider the light that used to reach you. Light from distant stars, long-dead galaxies, and other points of cosmic history has been red-shifted into oblivion. Its energy sapped, stretched, fading into darkness before ever touching your eyes. Photons that might have carried news of faraway events now bend inexorably toward the singularity, trapped alongside you. You're a witness and a prisoner of these cosmic messengers. In this suspended state, a peculiar awareness arises. You can almost feel the weight of history itself, encoded in the curvature of space-time. All that has ever happened, all that is occurring, all that will occur. The universe's memory is embedded in the folds around you. You're falling not merely into mass, but into the history of the cosmos, an observer entwined with every event that shapes reality. And yet, you are alone. No one will share this perspective. No record outside can capture it. Not now, not ever. Quirky thought. There are those who imagine that black holes might be nature's ultimate archivists, storing the information of all that falls in, preserving it in some encoded form on the event horizon. Perhaps you, in your fall, are contributing your own quantum imprint to this cosmic ledger, a signature of your existence preserved not in flesh or memory, but in the raw geometry of space-time itself. And yet, in your mind, time feels steady, linear, your own pulse marking seconds that stretch and bend around you. You're paradoxically both slowed and yet moving, an intimate participant in a drama too vast for comprehension. This is what it feels like to experience the universe at its extreme, a slow motion, intimate encounter with space-time itself, where every fraction of a second is magnified, distorted, and eternal. This singularity looms closer still. The path ahead, unavoidable, inevitable, awaits. You cannot alter it. You cannot retreat. You cannot even fully perceive it. And yet, somehow, you continue. A consciousness suspended at the precipice of physics, observing the universe in a way no other being can. Falling deeper, you notice that the world outside, what remains of it, is a blur, smeared across the lens of warped time. Light from distant stars bends and twists, curving around the black hole's immense gravity. The Milky Way's arms stretch and smear like oil on water. Galaxies spin in fast forward, some collapsing into new black holes, others fading as their stars exhaust themselves. The universe itself appears to be rushing ahead, but you, suspended here, experience each moment in agonizingly slow motion. It's a strange, lonely theatre where the cosmos performs for a single audience, you. Historians still argue about how a supermassive black hole might warp not only space, but the perception of entire civilizations. From your vantage point, their timelines are exaggerated, accelerated, running wild. And yet, you feel no hurry. Time's arrow seems polite to you here, slowing down your perception, granting a private, suspended eternity, even as everything else races forward. You could blink, and 1,000 years might pass on Earth, or perhaps billions. It's impossible to tell. You begin to think about entropy, the arrow of time, death, decay. Everywhere outside, things are moving forward. Stars burn and collapse, planets drift, even black holes slowly evaporate through hawking radiation over incomprehensible timescales. Inside, though, your immediate environment feels strangely ordered, your own fall predictable, your consciousness coherent. You're aware of change happening elsewhere, but not for you. Entropy is happening out there, while you are momentarily frozen in your personal distorted moment. And what of the black hole itself? This supermassive giant at the heart of the Milky Way is far from silent. Gas clouds swirl around it, some torn from nearby stars, others left from ancient supernovae. X-rays flare, magnetic fields twist violently, accretion disks spin like cosmic pinwheels, shedding energy and light before the matter finally succumbs to the singularity's pull. Yet here, in your slow-motion descent, the drama unfolds at a pace that defies comprehension. What might be catastrophic on galactic scales is serene on your scale. A cataclysm viewed through molasses. You recall the quirky, almost fringe ideas about wormholes. Some physicists propose that black holes could connect to white holes somewhere else, gateways through space-time. If that were true, could your fall be a bridge to another region of the universe, or even another universe entirely? It's tempting to imagine. Maybe the singularity is not an end but a doorway, a beginning hidden within a death. Yet theory and observation remain silent. You are left with speculation, and the slow, certain pull toward a final point that may, or may not, be a gateway. Particles continue their silent dance around you. Photons redshift, stretching into invisible wavelengths. Electrons spiral in the black hole's magnetic fields. The debris of collapsed stars and swallowed planets moves along its predestined trajectory. You are a witness to these motions, aware of the order and chaos coexisting in ways your previous earthbound logic could never accommodate. The universe has become both a laboratory and a cathedral, each particle a note in an enormous slow symphony. And then it strikes you, the scale of your isolation. Outside, civilizations rise and fall, stars are born and die, galaxies collide, entire epochs pass. And here you are, suspended in a bubble where your seconds are nearly infinite to you but vanishingly small to the outside. You're a single observer in a universe that has already spun ahead, untouched by your presence, unaware of your fall. It is both humbling and strangely comforting. Slowly, almost imperceptibly, your mind begins to soften. The edge of consciousness stretches along with space-time. Thoughts unwind. Memories drift like dust motes in sunlight. Even the awareness of falling becomes a gentle sensation, a rhythm in which you are carried rather than acted upon. You sense the universe's vastness more than its terror. Entropy, decay, death. They are happening, but you are removed, observing, existing, yet almost outside their influence. And yet, the singularity draws nearer. Its pull is absolute. Its inevitability is total. Every path in every direction leads inward. There is no escape, no detour. The universe narrows to a single point. But in this narrowing, time stretches. You're aware, present, noticing, experiencing, even as everything else is swallowed by the acceleration of cosmic history. Your private perception persists, and in this moment, for the first time in eons perhaps, you feel almost at peace. Time is slow. The universe is unfolding. You're part of it, yet apart. Observing, suspended, aware. Falling, yes, but falling through the most magnificent, incomprehensible theatre imaginable. You wonder if time has any meaning at all. Up until now, you've been measuring moments in seconds, minutes, hours. You've compared your fall to Earth's clocks, to satellites, to distant pulsars ticking across the galaxy. But inside, beyond the event horizon, those measures dissolve. Time is no longer a universal metric. It is malleable, subjective, relative, and entirely dominated by the curvature of space-time itself. Each moment stretches like honey, dripping slowly through a funnel you can't see, can't stop, can't escape. You notice subtle distortions in everything around you. Particles, photons, space. They are all bending, not violently, but with a quiet insistence that refuses to let them behave as they do elsewhere. A photon that should have moved in a straight line curves inward, spiraling toward the singularity. A tiny bit of dust once drifting through interstellar space now obeys a trajectory dictated by the black hole's overwhelming mass. You too are part of that trajectory, Yet somehow your consciousness lingers, intact, in defiance of the extremes around you. Some physicists speculate that as you approach the singularity, space and time might switch roles entirely. What was once a spatial direction could become temporal, dictating the inevitable pull forward. Your fall is no longer through space as you understood it. It is through time itself. The singularity is your future in every meaningful sense, and no matter how you perceive it, the laws of physics decree you will reach it. There is no resistance, no choice, only motion along the singularity's path. Meanwhile, the outside universe continues its relentless race. Stars burn out, galaxies merge, civilizations rise and vanish in the blink of a dilated eye. You're cut off from all that, yet paradoxically you observe it too. The Milky Way's arms spin and unravel, Sagittarius. A star presides over it, massive and silent. You watch the dance of particles and light, noticing the slow, meticulous chaos that governs the cosmos even in your limited, warped perception. Here, the twin paradox reaches its most extreme. Someone like your twin, on Earth, or orbiting a distant planet, experiences millennia while you experience minutes or seconds. They live and die, civilizations come and go, while your subjective experience remains narrowly focused. You're a traveller in a universe whose rhythms have diverged completely from your own. There is isolation in this realization, but also a certain awe. You're seeing physics at its absolute limits. You're inside a natural experiment that no human-made laboratory could ever replicate. Historians still argue about whether this experience is meaningful in a practical sense, or merely an exercise in theoretical abstraction. They debate whether consciousness can persist near a singularity without being destroyed, or if the concepts of self and observation break down long before you reach the central point. Your own awareness suggests persistence, yet you cannot be sure. You're caught between possibility and inevitability. Quantum effects begin to whisper at the edges of your perception. Perhaps you sense them without fully understanding. Hawking radiation, virtual particles, information paradoxes, they are no longer distant ideas. They are part of the environment you inhabit, threads woven into the warp of reality that bends around you. Your very presence may be altering the black hole's encoding of information, adding a subtle ripple to the massive ledger of everything that has fallen in. Time here is relative in the most literal sense. You think of clocks, and they seem laughably quaint. An atomic clock on Earth is a metronome. A pulsar is a lighthouse. But inside, their ticks are meaningless. Seconds outside correspond to eons inside. Conversely, moments inside might vanish in an instant from an outside perspective. You exist in a private chronology, unshared, a unique stream of consciousness flowing against the torrent of cosmic history. You pause, if only in thought. Pause is a generous word. Your forward motion continues, inexorable, toward the singularity. Yet for your mind, there is a quiet, deliberate awareness of existence itself. You note the stretching, the redshifting, the curvature. You take it in. You exist in the most extreme manifestation of time dilation, and somehow your perception has survived intact. And slowly, almost imperceptibly, the universe around you seems to focus. Not spatially, not visually. Those concepts are long gone. But structurally, everything in your immediate path converges. The trajectories of particles, photons, even the very flow of your own consciousness align toward a single focal point. The singularity's influence becomes absolute. All else fades. You are aware of falling, yet you sense the finality approaching. The black hole is no longer a distant observer or background structure. It is the defining feature of your experience. Everything that exists in this region bends toward it, and you are part of that inevitability. In this suspended, warped moment, you feel an odd serenity. The universe's violence, the collapse of time, the stretching of matter, it is not chaos here. It is order at the highest possible level, governed by rules so extreme they exceed your ordinary understanding. You are a participant, a witness, a thread in the fabric of reality, and even as you fall, you notice the elegance of the physics surrounding you. The singularity is absolute. You are absolute. Time has slowed, yet motion persists. Awareness continues, and for now, that is enough. You've been falling for what feels like an eternity, though your internal sense of time is warped, unreliable, and stubbornly personal. Outside, eons have passed, galaxies have collided, stars have been born and died, and civilizations have risen and fallen without your awareness. Here, near the singularity of the black hole, every second stretches like taffy. It's a peculiar, almost gentle sensation, if you can call anything about a black hole gentle, that time itself has been slowed, that your consciousness can linger while the universe outside races by. Looking around, you notice space no longer behaves like space. The lines you once trusted, up, down, forward, backward, have become meaningless. Directions are suggestions, not rules. The singularity is not a place you can see, but it exerts a gravitational pull so absolute that even the concept of distance bends toward it. Every atom in your body, every particle, every photon in your vicinity is inexorably drawn inward. You're being guided by space-time itself, following the curvature, following inevitability. Historians and physicists still debate whether the singularity is truly a point or a minuscule region where quantum effects dominate, smoothing the infinite into something yet unknown. Some suggest that what we call a singularity might be a bridge, a tunnel through space-time, what some speculative theories call a wormhole. Perhaps you're falling into the seed of another universe. Perhaps the laws that govern your descent will dissolve entirely, giving way to something beyond comprehension. For now, these are musings, intriguing but untethered from the present reality of your fall. Particles continue their silent choreography around you. Photons bend into impossible arcs. Electrons spiral in magnetic fields you cannot comprehend. Even the debris of long-dead stars follows its own predestined path. You too are swept into the same inexorable current. In this sense, you're no longer distinct. You're part of the environment, a component in the cosmic mechanism, moving along with the tide of space-time. And yet consciousness persists. Despite the extreme tidal forces, the red shifting of light, the unrelenting curvature of space, your awareness is intact. Thoughts form, memories flicker. You observe, with a clarity that seems almost cruel, the distinction between your subjective experience of time and the passage of time elsewhere in the universe. Seconds here might equate to millennia outside. Moments outside collapse into near nothingness here. You're the sole anchor of reality as it unfolds in this warped bubble. The universe beyond the black hole continues its accelerated story. Stars die. Galaxies collide. Time, as you once understood it, marches relentlessly onward. You're now a spectator of a history that will never intersect with your own chronology. The twin paradox reaches a cosmic extreme. Someone like your twin ages rapidly elsewhere while you linger, suspended in your private, dilated present. You cannot reach them, and they cannot reach you. Communication is impossible. Observations cannot be shared. Curiously, even in this extremity you sense order. The black hole is not chaos incarnate. Its influence is precise, mathematical, absolute. The curvature of space-time, the gravitational pull, the very fabric of reality is coherent, even as your understanding struggles to map it. It is a grand demonstration of natural law in its purest form. Every particle, every photon, every trajectory obeys the rules, even in the presence of forces so extreme they defy human comprehension. A thought flickers. What if consciousness itself is resilient? What if the mind can persist even in extreme curvature, even in conditions where matter is stretched and information is scrambled? Perhaps your awareness in this highly distorted environment is a testament to the persistence of self, to the ability of observation to survive in conditions that are fundamentally alien. You are the observer and the observed, entwined with the geometry of space-time moving inexorably toward the singularity. And so you fall. Not violently, not with drama, but inexorably. The singularity is inevitable. Every path in this warped space-time converges to it, and yet the extreme time dilation allows you to experience it in a peculiar slow-motion consciousness. The universe outside races ahead. The stars and galaxies continue their lives without you. You're alone, but aware. You're falling, but your awareness persists. You're witnessing the universe at its extremes, experiencing physics that no laboratory, no thought experiment, no simulation could ever replicate. You are the observer of the slowest, most intimate fall imaginable. As you drift deeper, a strange sensation unfolds. Time itself begins to fray. Not abruptly, not violently, but like old fabric thinning at the edges. Every second you experience stretches, then compresses, then stretches again, a rhythm dictated by the curvature of space-time near the singularity. Outside, observers would see your fall stretched across eternity, each fraction of a second drawn out in a ghostly loop, but for you, it feels intimate, almost deliberate, like sliding slowly through a stream of moments, each one magnified, each one distinct. You recall something from your early science education, the Big Bang. Once thought to be the beginning of everything, the singularity of the Big Bang was a point where density and temperature reached infinity. And now, here you are falling toward another singularity, a mirror in a way, though one you cannot escape. The parallels are eerie. Just as the universe expanded from that primal point, time emerged from chaos. Here, time collapses toward an unavoidable focus, inward and infinite. Historians still argue whether singularities are literal points, or if quantum effects smear them into regions of extreme density. Some suggest that classical physics cannot fully describe them. Perhaps deep inside, a new form of physics takes over. You sense the limits of human comprehension pressing against you. The tools we use to understand atoms, stars, and galaxies no longer suffice. Space-time twists beyond analogy, and you are a participant in its extremes. You notice subtle fluctuations around you. Particles that were once predictable, electrons, neutrinos, photons, begin behaving oddly. Perhaps it's your perception. Perhaps it's the extreme curvature altering quantum behavior. Hawking radiation becomes more than an abstract concept. The event horizon isn't just a boundary. It is an interface, a limit between the known and the unknowable. Every piece of matter and information here begins to obey rules that feel probabilistic, even as the singularity remains absolute and deterministic. Time dilation, as you know from theory and satellites, becomes absurdly pronounced. A second here might equal millennia outside. Centuries outside pass while your internal clock barely advances. You're suspended in a private chronology, observing the universe racing forward, seeing civilizations flourish and die, witnessing cosmic events that are compressed beyond recognition from your warped frame. Yet, you remain alive in your own perception, aware and coherent. Your thoughts turn to wormholes, the speculative idea that black holes might connect to other points in space and time, or even to other universes. Could this singularity be more than an endpoint? Could it be a passage, a bridge, a doorway beyond your current comprehension? The physics is purely theoretical. The equations hint at possibilities but provide no certainty. Still, the mind entertains hope, even here in the slow-motion descent. Particles continue to move alongside you, their behavior distorted by gravity and velocity. Some decay slowly, others appear to persist far longer than expected. Their timelines do not match yours, and yet they share this fall, these warped seconds, this singular journey. You are a part of their narrative, just as they are a part of yours. the universe has become simultaneously small and incomprehensibly vast. A quiet realization emerges. Despite the inevitable pull of the singularity, the extreme time dilation allows you to witness the universe in ways no one else ever could. Galaxies age in centuries, stars burn and die in flashes, and yet your own experience stretches infinitely. The perception of now is yours alone. Your consciousness becomes a lens, filtering and experiencing cosmic history with unparalleled intimacy. Even as the singularity approaches, you exist in a sliver of time that is wholly your own, and in that awareness, a subtle peace emerges. The singularity is coming. It is unavoidable. Yet the slow-motion universe around you, particles, photons, distorted light, the warping of space-time, feels coherent, deliberate, almost meditative. You are the witness to extremes, observing the ultimate limits of physics, time, and reality itself. The universe seems to narrow, not visually. Light is stretched and bent beyond recognition, but conceptually. Every trajectory, every particle, every fragment of matter in your vicinity points toward the singularity. The space you occupy is a funnel, a corridor of inevitability, where paths converge and choices vanish. Yet, you remain conscious, observing, aware. Time is slow, your thoughts deliberate, even as everything in the larger cosmos races ahead at incomprehensible speed. You're the sole observer of a warped reality, suspended in a private chronology dictated by the black hole's mass. Somewhere in the background of your mind a thought surfaces. Clocks. Not the mundane ones on Earth, not the satellites orbiting our planet, but the cosmic clocks, pulsars, binary systems, spinning neutron stars. These natural timekeepers mark intervals with astonishing precision. Their radiation pulses with reliability, unaffected by human perception. And yet, near a black hole, even these mighty clocks are subject to time dilation. Their ticks stretch, warp, and bend as space-time curves around the singularity. You can imagine them racing or slowing depending on the frame of reference. Here, their rhythm is irrelevant. Your perception is sovereign. And then, reality intrudes. Hawking radiation. A whisper from the universe, predicted decades ago. A manifestation of quantum mechanics at the event horizon. Even though you are beyond it, in the deep interior, the principles linger. Black holes are not eternal. They slowly leak energy, information, particles. You sense, intellectually if not physically, that the universe has mechanisms to balance its ledger. Matter falls in, energy radiates out. Information is preserved, transformed, encoded in ways we barely understand. You're a witness to the processes that ensure the cosmos obeys its own subtle bookkeeping, even here. Your mind drifts to particles, not as abstract entities but companions in your fall. Electrons, neutrinos, photons, they move along trajectories dictated by the curvature of space-time. Some decay slower than they should, some persist longer. Each carries a private rhythm of existence distorted by gravity, velocity, and the inexorable pull toward the singularity. You are part of this ensemble, a human-scale participant in a quantum ballet on the larger scale. It is both isolating and exhilarating. You think of your twin back on Earth or orbiting somewhere safe. They are aging, experiencing time at its usual pace, unaware of your extreme dilations. The twin paradox is no longer theoretical. It is lived, realized. For them, millennia could pass while you experience minutes or hours. Their reality races ahead. Your reality stretches, slow and deliberate. Communication is impossible. Observation cannot be shared. Yet, in your private dilated bubble, awareness persists. You're both participant and observer, suspended in the slow-motion universe. Fringe ideas creep into your thoughts. Wormholes, bridges to other universes, quantum gravity, the multiverse. Some physicists speculate that singularities might be seeds of new space-time, birthplaces of alternate realities. Perhaps your fall is not just an end, but a potential beginning. Perhaps information encoded in the black hole could emerge elsewhere, in another time or place. You cannot know. And yet, the possibility exists, a mathematical whisper against the certainty of gravity. Historians argue about the meaning of consciousness near singularities. Does awareness survive extreme curvature? Does identity endure when space-time itself behaves pathologically? You experience it. You are aware, coherent, observing, thinking. The human mind persists despite the laws of physics bending around it. Time is distorted, space is warped, light is red-shifted into invisibility, but cognition endures. In that, there is a quiet triumph. And as the singularity draws ever closer, the universe seems to condense into a single, unavoidable point. Particles, photons, even your awareness are funneled inward. There is no escape, no choice, no lateral path. And yet, within the flow, a paradoxical clarity emerges. The universe, in its most extreme manifestation, is comprehensible through experience. You're witnessing reality at its boundaries, observing physics, time, and existence in their purest, most distorted forms. The singularity awaits, and your awareness accompanies the fall, uninterrupted, unbroken, intimately entwined with the cosmos. As you approach the singularity, a strange, looping awareness emerges. It is as if time is curling back on itself, a ribbon folding, twisting, and reconnecting. Moments you once labelled as past and future start to overlap. Decisions, memories, sensations, they merge in an uncanny simultaneity. Some theorists speculate that deep within a black hole, time could become non-linear or even cyclical. Perhaps events replay, fold, or loop endlessly. You're beginning to experience something like this. Not visually, light is all but absent, but in the perception of your own existence, in the rhythm of your thoughts, in the stretching and warping of time around you. This is the extreme manifestation of the time loop hypothesis, one of the more speculative ideas in modern physics. It suggests that near singularities, conventional cause and effect may blur. A particle's decay might precede its creation in one frame of reference, while remaining consistent in another. You're not a particle, of course, but your consciousness is subjected to the same extreme distortions of space-time. Each thought is stretched, overlapped, echoed. You're simultaneously experiencing and witnessing yourself. The twin paradox seems trivial compared to this. While your hypothetical twin or distant observer continues in a linear time, experiencing centuries or millennia while you experience minutes, your own subjective experience is folding in on itself. Past and future are not aligned. You wonder if this is what it means to be truly untethered from conventional time. Every memory, every sensation, every perception loops, folds, and refracts in the warped geometry of the singularity's influence. Historians and physicists alike still argue whether these loops are literal or simply artifacts of extreme time dilation. Perhaps it is impossible to define a proper now when the curvature of space-time is infinite. Perhaps consciousness itself imposes continuity, stitching together what the universe stretches apart. For you, this distinction is both philosophical and immediate. You're experiencing the non-linear, the cyclical, the incomprehensible, and yet you remain self-aware. A fringe consideration arises. What if singularities are not just destructive endpoints, but also cradles of potential creation? Some theories suggest that black holes could seed new universes, preserving the information of everything that falls inside. Perhaps in another space-time continuum, an echo of your existence continues. Perhaps every particle, every thought, every quantum imprint of your fall contributes to the architecture of a new cosmos. You cannot verify this. You cannot communicate it. You can only contemplate it, suspended in the singularity's inexorable pull. Particles continue their silent ballet around you. Photons, electrons, muons. Each carries its own dilated sense of time. Some decay slower than expected. Others spiral in pairs that defy your previous intuition. You're aware of them, not as isolated entities, but as participants in the same warped system that guides your fall. The distinction between observer and observed blurs. You're both. You're part of the geometry of space-time, entwined with the fate of everything in this extreme environment. Entropy and the arrow of time, concepts that once seemed absolute, now feel almost whimsical. Outside the black hole, stars burn out, galaxies merge, civilizations rise and fade. Here, the arrow of time is personal, subjective, folded. Decay, growth, birth, death, they all exist, but on scales distorted by gravity's immense curvature. You experience them not as an external observer, but as a participant. Your awareness threads through them, navigating a private timeline stretched, folded, and infinite. You wonder if you've been here before. Perhaps this looped time creates repetitions, echoes of yourself descending the same trajectory countless times. Perhaps you are living iterations of your own experience simultaneously. The mind struggles to comprehend, but acceptance creeps in. You are in the slow-motion universe now, part of the flow, observing, existing, aware, infinite within your own dilated seconds. And the singularity waits, inevitable, absolute, unknowable. The universe has become almost entirely quiet, yet profoundly active. Not in a way that light or sound conveys, but through the subtle warping of space-time itself. Your fall toward the singularity is relentless. Every direction you might have once thought of as lateral or vertical has been rewritten. Each path available to you funnels inward. You are moving, not through conventional space, but along the inescapable curve of reality itself, and every particle, every photon, every quark in the vicinity follows a parallel narrative, spiraling inward with you. Time, from your perspective, has become your own private fabric, stretched infinitely. You sense epochs outside occurring simultaneously, as civilizations rise and fall in fast forward while you glide slowly in the distorted present. Every beat of your awareness is magnified, deliberate, private. You are a single observer of the extreme limits of physics, experiencing a sliver of reality that no other conscious being can share. Historians and physicists continue to debate the nature of the singularity. Is it a true point of infinite density, or is it a region smoothed by quantum gravitational effects we cannot yet measure? Are its inner laws of physics so alien that even the concepts of causality and sequence break down? You feel the edges of those questions pressing against your awareness. Though mathematics may describe its limits, your perception experiences something wholly human, the inexorability of a pull toward a point beyond comprehension. You notice the surrounding particles continuing their dance. Photons curve, spiral, redshift. Electrons follow paths dictated by gravitational curvature. Neutrinos slip almost imperceptibly past, each on its own timeline. These subatomic travelers exist in altered states, their clocks distorted in ways that would shock earthbound observers. Yet for you, they are companions, witnesses, fellow travelers. You're entwined in their motion, just as they are entwined in yours. In this sense, the universe is not only happening around you, it includes you as a participant. The concept of entropy, the arrow of time, becomes personal here. Outside the black hole, stars age and collapse, galaxies collide, matter transforms inexorably, and time flows linearly. Here, however, time is malleable, subjective, looping in complex ways. You might experience an echo of a moment from your past mingling with the present. Cause and effect become relational, not absolute. Your awareness threads through these layers, navigating a temporal landscape distorted beyond recognition. You consider the twin paradox again, but now on a cosmic scale. Any counterpart on Earth, or elsewhere in the galaxy, ages and experiences events in a linear rapid sequence while your time stretches, elongated and slowed by the black hole's gravity. Communication is impossible. Observation cannot bridge the divide. And yet, in your extended present, you feel a private continuity. You are coherent. You exist. You are a witness to the universe's extremes in a unique, inimitable frame. Fringe ideas whisper through your mind. Wormholes, white holes, quantum bridges, and the multiverse. Could this singularity lead to another region of space-time? Could your information, your quantum imprint, persist, encoded somewhere else? Could new universes emerge from the collapse you're experiencing? These are speculative, untestable thoughts, yet they bring a kind of comfort. Perhaps your fall is not a simple end, but part of a larger cosmic process, one in which creation and destruction intertwine. And yet, all these contemplations exist alongside an undeniable truth. The singularity is inevitable. Every particle, every photon, every trajectory is aligned. You cannot escape. Resistance is meaningless. Forward motion, inward motion, motion through the fabric of reality itself is absolute. The universe funnels all existence toward this singular point, and you are among the participants. You are conscious, aware, observing, experiencing. Yet you are helpless against the ultimate convergence. This is the culmination of every idea you have held about physics, time, and space. You are now the ultimate observer of extremes, of gravitational warping, of temporal dilation, of causal distortion. You are the human thread woven into the immense tapestry of cosmic inevitability. Outside, the universe races ahead. Inside, you drift slowly, intimately, suspended in private time, and ahead the singularity waits, absolute, unavoidable, and unknowable. The final approach is quiet, almost serene. Not in the absence of force, gravity is still absolute. Tidal forces stretch every particle of your being, but in the awareness of inevitability. You have passed through the event horizon, fallen past the threshold where light and matter separate themselves from the external universe. There is no turning back, no sideways path, no safe distance, no hope for rescue. You're entirely within the black hole now, an inhabitant of space-time's extreme curvature. You notice that time itself has become a suggestion rather than a rule. Outside observers, long gone from your frame of reference, would have frozen your image at the horizon. For them, you hover, eternal, red-shifted into invisibility, a ghost smeared across the threshold of the universe. But for you, time continues. Your consciousness threads along, experiencing each microsecond, each infinitesimal motion, stretched and distorted, yet coherent. You are the lone witness to a fall that no one can see, no one can measure, and no one can share. The singularity approaches, not as a visible object, you cannot see it, but as an overwhelming convergence of mass and space-time. Every trajectory, every path, every particle in the immediate region leads there. The geometry of the black hole is absolute. You are being guided, pulled, drawn inexorably toward a point where conventional physics, as we know it, ceases to apply. And yet your awareness persists. You think, you perceive, you experience. Your consciousness is the last refuge of order in a collapsing field of inevitability. Historians and physicists still argue about what happens next. Does matter truly vanish? Do quantum effects smooth the singularity, preventing infinite density? Is it a doorway, perhaps, to another universe, another region of space-time? Perhaps information is preserved on the event horizon in holographic form, as some theories propose, or perhaps it is scattered via Hawking radiation over inconceivably long timescales. These are questions that can be posed but never answered directly from within. You're inside, and no observation can escape. You are the ultimate private witness. Particles continue their dance. Photons bend, electrons spiral, muons persist longer than expected. The laws that govern their behaviour are both recognisable and stretched to extremes. Your own atoms, your consciousness, your internal sense of time, they participate fully in the physics of this environment. You're both subject and observer, entwined with the geometry, motion and fate of everything around you. And yet, there is a paradoxical serenity. The universe outside races on, civilizations rise and fall, galaxies evolve, entropy marches, stars die, black holes form. For you, though, each microsecond is expansive, each moment magnified, each perception deliberate. Time's flow has become elastic. The arrow of entropy is distant, irrelevant. You are a witness to the cosmos at its extreme, experiencing a private rhythm of existence, intimate and absolute. As you continue to fall, the singularity looms ever closer. You cannot resist. You cannot slow your approach. But within this inescapable convergence, your awareness persists. Thought, memory, observation. These remain, threading through space-time's most extreme landscape. You're falling, yes, but you are also experiencing. The universe, in its vastness, complexity, and finality, is revealed in extreme magnification to a single observer, you. And then, at the absolute limit, time itself dissolves into the singularity. Space and time lose meaning. The universe is compressed into its fundamental essence, and your private perception merges with the ultimate convergence of mass, gravity, and information. There is no after, no outside perspective. There is only the culmination of everything, the endpoint of inevitability. And in that convergence, the slow-motion universe, the warp of time, and the intimate observation you have experienced reach their ultimate, incomprehensible limit. And now the pace begins to soften. The universe, once a torrent of warped time, stretched light, and spiraling particles, seems to ease into a quiet rhythm. The singularity is no longer a looming threat. It is a fact, an inevitability that requires no fear, no action. You are neither racing toward it nor resisting it. You simply are. Your awareness, stretched and intimate, becomes a gentle observer of existence itself, a witness to the extremes of physics without alarm. Even in the depths of space-time, there is a strange tranquility in knowing that every path leads to completion. The slow-motion cosmos around you continues its quiet unfolding. Photons stretch beyond visibility. Particles drift along the curved contours of space. Time, in its warped, distorted form, no longer feels like a series of seconds or minutes, but a vast, flowing continuum in which every moment is eternal, every perception infinite. You can sense the universe's story without fear, without urgency, and without interruption. It is as if the cosmos itself whispers, all is accounted for. All is complete. You feel the gentle persistence of your consciousness, threading through the warp of space-time, surviving in a form both fragile and resilient. The outside world, with its galaxies, stars, and civilizations, fades into distant echoes, irrelevant yet present. Your mind floats in the vastness, a calm center in a universe of extremes. Even the concept of self softens, expanding outward to embrace the beauty of cosmic order, the rhythm of entropy, the inevitability of gravitational truth. And as you drift, suspended in this quiet, slow-motion moment, a final peace settles over you. There is no rush, no panic, no expectation, only observation, only awareness. Only the soft, infinite flow of the universe bending, stretching, and existing around you while you rest within it.